So question 11, it asks you to draw a ray diagram. This question is on optics and lenses. So we are going to look at a converging lens and looking at an image which is diminished, or it is smaller than the original object, and it's real. So this is where an object can be projected onto a screen and the rays actually cross on the ray diagram. So let's have a look at when that could be possible. Now, before you even start, to answer this question, for a diminished image from a real object, can only be produced if the object is placed beyond two focal lengths. So the object's position has to be beyond two focal lengths. So wherever you decide your focal length is on the ray diagrams, your focal length multiplied by twice. If your object is beyond that, you will get your rays converge and produce an image which is much smaller in size than the object and is diminished. If you place your object at two focal lengths, what you'll see is the object size is the same as the image size. And if you place your object between two focal lengths and a focal length, the image on this side will be magnified and inverted. If you place the object at the focal point, there will be no image created on this side. And if you place the object closer than the focal point to the lens, you will see a virtual image which will be produced on this side. Neither of these are what the question's asking for, so you really need to know your ray diagrams before you start this question. If you are doing trial and error, you will find that a lot of time is going to be wasted trying to figure this out. Okay, then you'll have to rush the latter questions. So here we are. We've got the object, and I've drawn, as most ray diagrams will do in majority of the textbook, as an arrow. So this could be a tree, an object, but we're going to draw it as an arrow. You need to start doing this as well in your diagrams. This here is the principal axis. In the question, it asks for label the object, which we have, label the image, which we have, and label the principal focus. That's the difference. That's different to the principal axis, which is that line there. The focal point is what they're asking for, the principal foci, another word for focal point. And with a lens, you can put the focal point on both sides symmetrically and 2 times the focal point on both sides symmetrically. So when light hits the object, it bounces off in all directions. We are only considering two reflections of the object. One that bounces off and makes its way parallel to the principal axis, hits the lens at 90 degrees, relatively speaking, and then that will always go through the focal point. So any ray coming in parallel will always converge through the focal point and keep on going. And through the center, we are making the assumption there's very little refraction taking place there. So the ray will go past straight through. And where these two rays converge, that's where the image is produced. And we draw an arrow from the principal axis down to where these two cross, and that's where our image is. And we can clearly see that the size of this image is smaller than the size of the object. Hence, we have satisfied the question, diminished image, and it's from a real object here. And when we draw out a lens, a converging lens, the arrows point outwards, so making sure that we draw everything correctly here. Okay, right. Question part B. It's really important to draw pictures when there's a lot of information. It's about lenses, it's talking about focal lengths, it's talking about the distance between objects and the lens. So why not draw something out somewhere on the page. So let's read this out. A student did an experiment. We got a focal length is 50 centimeters. Okay. She places an object and the screen a fixed distance of 200 centimeters apart. So there's your object and there's your screen. We know that's 200 centimeters away. Okay, we know that with the lens is 128 centimeters from the object. Okay, so there's the object, there's a lens, there's a screen. So that's 128 centimeters from the object. That's where the lens is. So we know that if this is 200 centimeters, that's 128. Then the distance from the lens to the screen is 72 centimeters. Now look how much that picture can help. Let's have a look at the answer. It's a question is asked for the focal length of the lens. So we know there is a relationship between the focal length, the distance from the lens to the object, which is u, from the lens to where the image is produced, which is v, and it says that a sharp image is produced on the screen. So that's where the image is. So that's v, and that's u. Okay, so that's the distance from the object to the lens, and then from the lens to where the image is produced, and we know that the image is produced on the screen. So getting this picture right would have got you that 72 centimeters, and that is the 200 minus 128, which is 72 centimeters. That picks you up a mark. Now we know that we should be using and working with standard units. So centimeters to meters, 1.28 meters and 0.72 meters respectively. Rearrange, you get 0.46 meters. It would have worked out if we used centimeters. The answer would have ended up in centimeters. But just remember that when we are looking at power of the lens, and when we're looking at 1 over f as being the power of the lens for other questions, that has to be in meters. So I'm using meters in my question, just to get into the habit of that. We know the magnification is the object, the image size divided by the object size, but that information is not given to us. But we also know it's the image distance from the lens and the object distance from the lens. That is also the magnification, and we know that is 0.72 and divided by 1.28, which is 0.56 as the magnification.